So first we import the libraries, okay, as you can see here, which we're going to use in the further code. Then we are giving the paths of training, test, and validation. Okay, then we are using image normalization function, okay, to convert the images like the pixels. Okay, then we are using data preprocessing library, which like data augmentation. Okay, so you can see like we have imported from TensorFlow, we have imported the processing, okay, data augmentation. So here we are giving the paths, okay. And once like it is here, you can see it is giving us the calculations how that we have in the training this much of images belonging to two classes, obviously for fake and the real, okay. And then we are using this, okay, like we are mapping the normalized image model, okay. So for normalizing each image, okay, once the data preprocessing is done, then we are doing we are implementing the model, okay. You can see here the CNN model we have, okay, with this many layers, okay, not too big, okay. Okay, so once that is done, then we compile the model. Basically, we give the loss function, loss matrices, okay, and the optimizer we initialized. After that, we train the model. Okay, we are given the 10 epochs. The 10 epochs, we can see we are getting this much accuracy, loss, well accuracy, and the well loss. Okay, once that is done, we do the testing. Okay, and save the model. If you wanna use in the deploy in the Flask app, so that we save the model. Okay, later that after that, the second code is the first code was using only CNN. The second code is using CNN and LSTM. Okay, for that we are imported necessary libraries. Okay, same thing we are doing, giving the paths. Okay, once that is done, we are proposing the images using the image generator. Okay, image data generator library. Okay, you can see here like all the things it takes care of, like target size, converts all the image into this size. Okay, create the patches. Okay, you see here same thing. Once that is done, we initialize the model. For the CNN, we are using the ResNet pre-trained model. Okay, from the LSTM, we have defined the layers of the LSTM, like yeah, LSTM. Okay, with the parameters units. Okay, once the model is done, okay, then we compile the model, give the learning rate, optimizer, loss, and everything. Okay, once that is done, we here train the model. Okay, you can see we have given training it for like 15 epochs, and you can see the accuracy here, loss and the well loss and well accuracy. Okay, and then we are just showing the graphs, okay, for the training accuracy, training loss, okay, all loss and accuracies. Okay, and then we we predict the classes, and we generate the graph for confusion metrics. Okay, the accuracy is not that good. Okay, that's why these results are like this. Okay, once after that we just evaluate the model, okay, and generate a classification report. Here you can see the overall accuracy is 60.60, like 60%. Okay, and then we ROC curve graph with plot. Okay, and yeah, then we just plot the graphs. Yeah, same thing, we are evaluating the model, testing the model, okay, checking the all the different matrices like F1, what was the error rate, what the G mean here. Okay, and we can, yeah, after that in the end we save the model if we want to use in the Flask app or not. Okay, okay, after that the next model is CNN transformers. Okay, CNN plus transformers. Okay, same thing, we are imported the libraries. We have we are here we are giving the initializing the parameters. Okay, and we are doing the pre-processing of the images, okay, of the dataset, and then we are using image data generators. Okay, data augmentation we are doing. Okay, the same thing, we are using a testing, and we are using only two things like training and validation. Okay, once that is done, we initialize the model. Okay, the model structures. Okay, the CNN, this part is for the CNN one, and this one is transformers, basically an encoder. Okay, and then we combine the model here. Okay, once that is done, we compile the model and we train the model here. Here we compile the model, we give the list topic, basically, yeah, like callbacks here we are defining in the early stopping. Like for example, like here we are training the model. For example, the use of these callbacks are like, for example, we are training model for many epochs. So if for some epochs 5 or 10, if the accuracy or the loss doesn't change, then it will stop automatically. So that's why we are using that. So for here you see this is accuracy, well loss. Okay, and the loss, the training accuracy and loss is good, but the validation accuracy is okay, but loss isn't good. Okay, and then we plot the graph for training and loss and validation accuracy and loss on. Then we are just creating the confusion matrices. Okay, well, then we check on the like testing data. Okay, here you can see the confusion graph. Same thing we are doing, we are just evaluating the model, testing the model, and seeing the accuracy, and the accuracy is this, like after classification report we are getting this accuracy. And same thing, we are just evaluating the model, we are generating the ROC curve. Okay, yeah, so once that, and the next code is CNN and the media pipe. Okay, same thing we have done, like we imported the libraries, we have given the paths, then we have to process like are we using augmentation, we have to prepare the data set. Okay, then we are initializing the media pipe. Okay, here we are, what media pipe does is like it extract the feature, like in the media we have the points for the faces also, we have the points, so it extracting the features of that. Okay, so that basically what media is doing. Okay, and then we are creating the CNN model. Okay, yeah, for training that specific features, okay, which was got from the media. Okay, once that is done, the model compilation all. Okay, then we train the model, so the accuracy for it is around this. Okay, not that good, so we will not use that. Yeah, we have tried just for something newer. Okay, for the learning we have used that. Okay, and here we are just plotting the graphs and testing the results and plotting the other matrices. Yeah, okay, that's it. This is the model which we not going to use. Okay, and in the end we have the end model, division transformer model. Okay, so we have imported like installed import necessary libraries, we imported the libraries. Okay, transformers and the torch, which is all we're going to use. Okay, and then we read the dataset, we give the dataset path and then the images and all. Okay, then we are just processing the dataset, and here we are just randomly checking what image is shown. Okay, we are just here we are just mapping the images and, and the like numbers to, like we have the real and fake, so we are just mapping like real belongs to like zero, and fake like zero belongs to the real and the one belongs to the fake. Okay, so we are just doing the mapping here. Okay, here we are just doing all the same things, they're processing the data sets. Okay, getting the training and testing data sets. Okay, once that done, then we are initializing model and all, we are using this pretend model. Okay, from the phase. Okay, from the transformers. Okay, and then once the model initialization is done, then we the yeah, we have the this functions to process the data set. Okay, yeah, once that is done, we are just giving the like once the model initialization and everything is done, the processing of the images is done. Okay, then we are yeah, here still we are like giving the parameters and all. Okay, yeah, then we define the trainer arguments. Okay, with this all these parameters we gonna use, like we have initialized the model, so we are giving here the model name and all. Okay, so here we have given the model name and all. Like all the parameters we are gonna use that. Okay, and then like we are given from to train like trainer function, okay, train argument. So here we gonna use that arguments. Okay, the model we have given is here we are given the model. Okay, and this after that we call the train function. Okay, it takes around more than an hour, and the training loss, the validation loss and accuracy, it everything seems very good. Okay, then we evaluate the model, so you can see the evaluation results. Okay, once that is done, we just see the matrices results. Okay, what was the taste loss, accuracy. Okay, and everything. Okay, once that is done, plot the graphs, matrices, and like confusion matrices, classification report. Okay, once that is done, everything seems good, like the results are very good, so we save the model. This model we're going to use in the Flask app. Okay, here you can see like we have the saved model. Okay, we are giving the saved model here, the the folder we are giving here path. Okay, and then we are like reading the model. Okay, so once the model loaded successfully, then we use the whatever the image is given to the whatever image and the model given to the uh, uh, like image and the video given to the model, it will predict. So I'll show you how it is going to predict. So yeah, just login. Okay, so first image. Okay, so I'll give the input, it will go to the backend like code. Here it will goes to the, here you can see here, sorry, sign up not here. Yeah, here you can see we are reading the file from the browser we got, then we give to the model. Okay, and like here the process one is like process function is this, which gives like process the image and gives to the model. Okay, the model gives the output like predict label and the confidence, and then we pass it to the browser and it shows us here. Okay, so if I show okay, this one the other image it will show us. Okay, this one is the now video I check. Video. Click on the string. Here it is showing the video with the results real and the accuracy, the confidence, what is the for real and what is for the fake.
Thank you friends for watching my video. If you are new then subscribe channel and share with your friend. Don't forget to like, comment and share. Thank you.